Good morning, everyone.
Morning.
Morning to everybody. First of all, it's a great pleasure for me to stay here with you.
Morning. Good morning.
Oh, yeah. Morning to everybody. Assalamu alaikum.
عليكم السلام.
عليكم السلام.
Good morning, Carlo. How are you? Mute.
Okay, Michele, good morning. Good morning, Ahmed.
I can hear you. I cannot hear you.
Can you hear me now? Ahmed, can you hear me now?
Okay, now, yes, yes.
Okay.
Good morning, Salim.
Good morning to you. How are you? Good morning to all.
Yeah, good
Fine.
morning. Yeah, hello.
Hello, Ahmed.
Oh, Professor Ahmed.
Yeah, hello. Nice to meet you.
It's all right on your side?
Yeah. Thank you for your attendance and your efforts.
It's a pleasure for us.
So now we have to send you the EcoCar background that to be used in the meetings.
Okay.
صباح الخير دكتور احمد.
صباح الخير. اهلا ابو عثمان.
الايكو كار اللي وراك الاسم جاي من اليمين لليسار مش من اليسار لليمين.
ما هو عامل مرر.
حاول خليها تقلبها.
بدك
صباح الخير. Good morning.
Morning,
everybody.
good morning, Professor Salman.
Salman. Yes, thank you. Good
Salman.
morning.
والله صاير شناح دكتور. يعني احنا ما كنا نجربها.
الورش الجاي
على المرايه خلاص.
لا هي عامله مرر لانه الكاميرا.
يعني I think that it is around 10 now.
Exactly 10.
Yeah, so we should be like on time, like European.
Okay, no problem.
Yeah. I think that we have now about how many? About 40 participants. It is expected that the number will be increased also, and we have. I think that we'll have more than 50.
Okay. How many students?
I think that most of them they are professors since we are still in Jordan now in like summer vacation. The semester will be started at the middle of October. So might be some students they are there, but many I think that most of them they are faculty members and professors at the university. At Sarah. Yeah, I think that now we have how many participants, Sarah? Okay.
50.
Yeah, very good. So I think that is a good number to be started. First of all, we would like to thank you all for attending. I think that this important workshops, which is related to the EcoCar projects. Also, would like to thank our partners from Italy that will give today the workshop. In fact, this project is very important for us in Jordan because it is related to very important topics, which is like electric and hybrid cars. And also in the last few years, we start to concentrate more on the vocational training and vocational topics. and this is what is needed. In fact, I want maybe to give you a brief about like EcoCar. I will not take more than 10 minutes, and then we will also follow the agenda that we have. So Sarah, you can maybe share the presentations, or let me, if I can also share it from my side about the EcoCar, or my, you can share it from yours. Okay, so yeah, please allow me to at least to inform you very quickly about the projects that we have. This project, which is called EcoCar. It is related to the like vocational training diploma in electric and hybrid cars. So University of Jordan is the leader of and coordinator of EcoCar projects, and we have like a team from different departments, from electrical, mechanical, mechatronics departments. And as we said, that the project aims to develop the capacities in the field of electric and hybrid cars in Jordan. Also, we need to strengthen cooperation between also the companies, stakeholders, and higher education institutions, and we'll establish also vocational training centers in Jordanian universities. We have also very good components which is related to the like establishing the networking from stakeholders. And last week or 2 weeks ago, we conducted also a workshop with the stakeholders. We have also a capacity building plan for academic and the students, and hopefully that the travel restrictions will be reduced. So we'll have like this capacity building program. Also, we'll accredit the programs and then integrate the courses with our program. Next. Also, we'll have, like as we said, that this vocational training diploma programs for the students, like vocational diploma who do not have access to the university, in addition to like establishing university enterprise cooperations. Yeah, this is like some indicators. Within, I think that next year we'll have like 8 programs in 8 Jordanian universities, in addition to like 8 labs. We'll have also e-learning platform that it will be launched for electric and hybrid cars, in addition to the like training for students, staff, and stakeholders. Yeah, about like as we said that the over aims of the EcoCar is that it is the same, that we need to improve our university capacity in the field of electric cars. And we have different work packages like preparation, development, quality plan, dissemination, and management. Yeah, I think that there is no need now to discuss this work packages, but at least we can go to the work package. I think that this is like about 4, where we have like the capacity building and this workshops that, yeah, this capacity building workshop with work package 3. We have like our partners in Athens, they are the lead of this work package, and we'll have like many workshops that will be conducted online and also in Jordan, in addition to Europe, for our staff. Next, Sarah. Yeah, I think that maybe within a few months, if the travel is allowed, we'll conduct also many face-to-face workshops in Jordan. In addition, we will establish the labs at 8 Jordanian universities. Next. Also, yeah, this is like the labs that we are looking to establish, and this is from our visits to some labs at some universities. This is at applied science universities, and also this is like Abu Khadr Automotive maintenance centers that we visited also the companies here in Jordan, also to prepare a curriculum according to the market needs. Yeah, and now our colleagues and professors from different Jordanian universities, the universities, they are working now to prepare the curriculum which will be ready, I think that within a few months. Next. Yeah, and we will have like 2 or 3 types of the diploma, since we are targeting like engineering students and also vocational students. So what we have like a professional diploma at the University of Jordan. It will be like at the level of the master after the students finish his bachelor degree. And also we'll have vocational diploma. This is also for the students who have like secondary examinations, either pass or fail. Next. Come on. Yeah, and this is about the quality that we have like also quality work package that will be also continuous improvement. In addition to the disseminations and some events that we have the project website, we have also social network and also management of the work package. This is the website that we invite you to visit the website. We'll have all our announcement at the website. Next, we have also a Facebook for the project. You can also see it. Also, we have a YouTube channels. So this is like a brief, as I promised you that to be on time, because we have like many colleagues who are non-members with us in the projects, and they were invited to attend this important workshop about the cars, about internal combustion engines. We try to introduce the projects. It will be like a 3 years projects. We are still at the first year of the projects. We are in the month now 7th of the projects, and we hope that it will be a tremendous progress during this like 3 years. Especially we have very excellent partners from Italy, from Germany, Budapest, from Greece, also from Spain. So we have 5 countries, 5 European. So we invite you that if you make a mute for your mic, our colleagues, that will, because maybe sometimes maybe if it is open, I don't know. Maybe Sarah, you can make it mute for our. Okay, so if you put us the agenda. Emily. As you can see that the agenda today will have like after this welcoming speech and introducing the projects. So we'll have Professor Michael Anatoni from UNIVAC in Italy. He will give us a presentation, a lecture about internal combustion engines in hybrid vehicles. Then we'll have another presentation by Professor Carlo Villanti about wheel-to-wheel LCA assessment. And then we have like about half an hour discussions and then closing. So please allow me to welcome Professor Michael. So please, Professor, you can now prepare your presentation and you start the presentations.
Yes, thank you. First of all, this is a great pleasure for me to stay with you in this important project that is very well coordinated. Compliments, Professor Ahmed. Very well coordinated. Can you hear me?
Thank you very much. Thank you, Professor. Thank you.
Yes. Now I will try to share my desktop. Can you see something?
Yeah, it's here.
Okay. So, thank you. Good morning. Salam alaikum.
Alaikum salam.
Alaikum salam.
Okay. Okay. Now, I will give you some information today because 1 hour is a very short time to give a lot of information about internal combustion engines. This is a list of topics that should be faced when we talk about internal combustion engines, starting from the mobility, the energy and environment, and something about the classification characteristics, thermodynamic cycles, because the engine is a thermal machine, and then something about power and torque characteristic curves, the gas exchange process, because the engine is an air breathing device. We need air and fuel. If you have air and fuel, it is easy to start combustion. But in these devices, the combustion is the times available for combustion are very short, milliseconds, 2 milliseconds, more or less, when an engine is rated at 3000 RPM. And the process of the charge, the gas exchange can be improved through supercharging, for example, with a turbine and a compressor. And the in-cylinder means everything that happens inside the cylinder, the charge motion, turbulence and turbulent intensity are very important to make a good combustion. And then according to the classification, SI means spark ignition, and CI means compression ignition. We have two possibilities to start the combustion: with a spark or through the compression of the gas. The gas must reach high pressure and temperature levels in order to start the combustion. And something about fuels we should discuss, and air pollution, because there is a huge interaction between engines and environment. ECU, electronic control units, heat transfer, and then hybrid vehicles. Obviously, today I will give you a brief introduction, and keep in mind that we are available to give you a seminar, also 1 week seminar, when the pandemic condition will allow us to travel. So, Jordan, these data are come from the International Energy Agency. In Jordan, sorry, I don't see all the, do you see all the screen?
Yes.
Oh, okay. Okay, balance. In Jordan, energy balance. This is a Sankey diagram. Energy balance in Jordan. You have a lot of energy for the transport sector, more or less the half of the all energy in input. And in the world, we have more or less the same percentages. The problem is the environment, because the interaction of the transport sector with the environment is very, very huge. This is the problem. This is the importance of the vehicle sector, the impact of the vehicle sector. We have a lot of energy. We have an energy problem, but keep in mind that the problem is the environment, not the fossil fuels, because the fossil fuels are available and will be available in the next decades. The problem is that we cannot emit CO2. The problem is the greenhouse effect. And the transport sector is very, very important on this impact. The engines, the internal combustion engine is a wonderful device, very, very wonderful device, because it can be, it can range, the power can range from few kilowatts to 50 megawatts. But the engine is always the same. Piston, cylinder liner, connecting rod, crankshaft is always the same. But something must to change if the power changes in these ranges. The problem is the environment. Just to give you an example, this is the time history of the evolution of the European regulation on engines. You can see, starting from Euro 0, more or less 1990, to Euro 6, 2016, the polluting emissions are decreasing in a dramatically way. So the research must be very, very important to give a contribution to the reduction of the polluting emissions. The problem is that the engine is very, very suitable to be used in the transport sector. It is a very complex device. And the problem is that usually a vehicle is managed in transient conditions, rapidly varying with time. And in this condition, the efficiency is very, very low, and the polluting emissions are very, very high. In hybrid vehicles, the engine management can be changed if compared to a conventional vehicle. We have a lot of layouts, series, parallel, and all the devices can allow to manage the engine in steady state condition. Keep in mind that the engine is a volumetric device. Volumetric means that we have a volume that must be filled and emptied along the thermodynamic cycle. So we cannot talk about steady state condition. Fixed point could be better, where torque, RPM, and then power are constant on average in time, constant on average, but they vary with time. And the combustion process is very, very complicated to manage this kind of condition. Okay, yes. I will provide you, I will give you this presentation if it is useful for the dissemination, okay?
Yeah, okay. It's useful.
Perfect. I will skip some slides. As already said, we have a volume that must be filled and emptied, and this volume must breathe air, and then we have the necessity to connect the volume with the environment, with the atmosphere. According to the classification, we can have two-strokes engines or four-strokes engines. And this is related to the number of revolution to perform one thermodynamic cycle. Two strokes means that we have an intake stroke, combustion, and exhaust along one rotation of the crankshaft. Four strokes means that we have an intake stroke, compression stroke, combustion, expansion, and exhaust. And this can be sorry, I have some problem with, sorry. My network.
Professor Michel.
I'm Carlo. Sarah, I'm Carlo. Michele has some problems with the connection. I will call him by phone now and see if I can solve those.
Is here he is.
Okay. So I will let you know in a minute.
Professor Michel, you are muted. Professor Mike, you are muted.
Okay, Sarah, can you hear me?
Yes.
Okay, I spoke with Michele. He has a problem with the computer, with the personal computer. Actually, I have an echo. Okay.
Yes, Dr. Carlo. I think you are muted, Dr. Carlo. We can't hear you.
Can you hear me now? Okay. So Michele has a problem with the personal computer. I have your echoes. Okay, now it works. Okay, Michele has a problem with the personal computer. So for the moment, he is not able to continue the presentation. He will try later on.
So we can start with you? Is
Yes,
it okay?
yes.
Okay.
So I will do mine, and then Michele, if possible, will follow up.
No worries. Okay, we can start with you,
Okay.
Carlo Vellante. Please share your screen now.
Yes, I'm opening it.
So our next presentation will be will-to-wheel LCA assessment. We are sorry for the inconvenience due to some technical issues. We will start now with Dr. Carlo Vellante from Univac University, and we will go back again with Professor Michele. Please, Dr. Carlo, the floor is yours.
Okay, thank you, Sarah. I think you can see my presentation, my screen.
Yeah, I will see it.
Okay. Okay, now it should go full screen. Okay, you see the presentation running?
Yeah, it's full screen now.
Okay. So Michele excuses very much, but he had a problem with the PC, which crashed. So it was not a connection problem. He's trying to fix it and to join us later on to finish his presentation. But no problems for the subjects because I can do mine before is no problem. So Michele was just told you something about the importance of energetical and environmental issues when speaking about transportation. My presentation will be mainly talking about this, so it will not be very technical. As far as I understood, among you there are not only professors but also technicians, students of various levels. So I will not be very technical in this presentation. I'll try to focus on the important aspects, but feel free to ask me whatever compliments and details you like about the single aspects during the presentation, if you prefer, but also later on in a Q&A, question and answer session after my presentation. We could speak about everything if you like. So this presentation will focus on the on some future scenarios for a sustainable mobility, and on the importance of the approaches we could have in evaluating the different alternatives we have we could use to make mobility more sustainable in future. Briefly speaking, in the mobility sector, we have many technology innovation drivers, so aspects that force the sector, the industrial sector, to change and to do it very quickly. The main innovation drivers in the last decades were these, and these four listed here. Firstly, in the 70s, you certainly know, you were a crucial part of this also as a Middle East country. The energy dependence from the OPEC petroleum production countries was the main issue to drive technology innovation in the mobility sector and in the energy sector overall. But then the attention was focused to other problems because not only the energy sources were concentrated in a small amount of space in the world, but soon became clear that this was also exhaustible, so that the amount of energy we have stored in the underground is not sufficient for a very long time horizon. So the problem became the sustainability of the energy energy fossil sources use in time for a long period. Just after that, but I mean, in a parallel path, many environmental problems arise, and environmental problems are of two types. We can speak about a small time space scale of impact environmental problem, and of wider time space scale impact environmental problems. What I mean, speaking about small time space scale impacts, we focus on the toxicity of air due to the combustions, mainly to the combustions made within meters, tenth of meters, hundred of meters from the point where we breathe the air. So the emissions of toxic substances which are done in air due to combustions have not time and space to dilute and to make air breathable and pure in the to be breathed. So the problem arises only if the emission sources are sufficiently near and concentrated to the place where we used to live and to breathe the air. So the problem may not arise if we continue using the same sources and the same technologies, so to burn the fuel sources to make combustions, but we basically move these combustions sufficiently away from the place where we breathe the air. So if we give time and space to the toxic pollutants to dilute within the air. So the problem is here and now. What I mean? I mean that the problem will solve itself in space and time. So if we remove the sources, the problem will be solved in a very narrow space and time horizon. A completely different problem is regarding a wider time-space scale impact. The most clear example of this kind of problems is the global energy warming due to greenhouse gases emissions. I know that maybe for the most of you is perfectly clear, but it's important to focus to the fact that these gases are not, most of them, mainly all, mostly all, are not toxic at all. So there is no problem of toxicity of air due to greenhouse gases emissions, but there is a huge problem about the effects on macroscopic parameters of the atmosphere, which may change the thermal balance of the atmosphere with respect to the extra-Earth environment, and especially with the sun. So the temperature of the Earth is changing due to the fact we are changing the composition of the atmosphere due to the emission of greenhouse gases. As you certainly know, the most relevant about among these gases is CO2, carbon dioxide, which again is not toxic at all. So the problem only arises because we are emitting so much carbon dioxide in the atmosphere, we can change the composition of the atmosphere overall. The problem is of a wider time scale. The space scale is the whole Earth. So is not there is no importance at all if the emissions of CO2 are made in India, in China, or in Italy. The effect of those will be practically the same for all the people in the Earth, independently from the emission point. Moreover, these emissions will will remain in the atmosphere for more than 100 years before being removed from the very low removing techniques which are present in the environment. For example, the absorption of CO2 from the from the seas, from the sea surfaces, or other very, very small and low and slow acting removing techniques. Okay, so what is the problem here? The problem is that again we must as a Earth overall reduce greenhouse gases emissions, not giving any importance to the place where the emissions are made, and we must do it now to have some perspective bettering in the situation within tens of years, because the inertia of the Earth overall in giving the effects of greenhouse gases concentration variations is very, very high. So the effects of what we did in the past is more and more present now, but the effect of what we will do to better the problem now will only be visible in the next decades. So it's already too late, probably, to have not to make the problem become very, very high and higher in the next decades. But we must do something about this. These are the technology drivers. So, more and more we are going on. The importance of these four and the weight of these four is changing. And nowadays, the importance of CO2 emissions is the main technology innovation driver in the automotive sector and in the mobility sector overall. It was not like this even 5 or 10 years ago. Okay. What are the main actions to be undertaken to solve these sustainability issues? There are many of possible actions to be undertaken at very different levels. One of these may be, lately we will focus on the more technological aspects, but please consider there are also social, economical, and political levels which may have an impact on the sustainability of the sector, which is maybe more, which is maybe higher than the one we can have at a technological level. So substituting the technology used for mobility. For example, an example of this is the vehicle use level. So firstly, we must act socially, politically, and personally to change our attitude about the vehicle use. So a vehicle perception is changing very, very much. during time, within generations. The attitude with which my young sons look at a vehicle is very, very different if you think at it to that which I looked at a vehicle when I was a guy. A vehicle was only 20 years ago, 30 years ago, was was not only a means of transportation, it was a symbol of prosperity, of speedness, of performances, of the way we approach it to life. Now things are changing, and the vehicle is more and more seen as a dirty thing, as a way we are changing the environment and the earth in a bad way. So obviously the attitude of people, of young people towards the vehicles and towards the, for example, also the size of the vehicles and to power, to speed, to vehicle performances is very, very different with respect to 20 years ago. Fortunately, this is like this because we must completely change our attitude towards vehicles and to our way to fulfill transportation demands. In a very, very short period of time, consider maybe only 10 years in some countries, especially in big cities, the attitude towards the vehicle will change completely. Probably families will living in the city centers, in big towns, will not have any vehicle of their property anymore. Because the attention is given now to mobility services. So in the city centers, no one in a very short period of time will have a property car anymore. He will use a car of property of a certain firm, selling mobility services to everybody. This will make the vehicles quantity around go down and down. And this will, why? Because vehicles will be much less, but they will be much more used. So the utilization factor of a vehicle will go higher and higher. And the vehicles sizes will change very, very much. Because if a vehicle knows that it must be used only within the city center, it may be sized more than a half less than an half than previous vehicles of property, which should have a multi performance attitude, making 2,000 kilometers a day or 50 kilometers each trip. So the mobility sector overall, especially automotive sector, will change very, very fastly, very, very deeply in the next decades. So the words you are already listening in these decades are car sharing, carpooling, vehicle leasing, transportation services. So everything of this is not going to the is going against the property of the vehicles. More can be done also at a driver style level. The power you need to, the energy you need to make a trip. So from an energy point of view, your transportation demand is normally much, much lower than the energy you use to fulfill that demand. What I mean? I mean that you maybe must do 10 kilometers to go from your house to your work site. How much energy do you need? Well, it depends on how much, on what vehicle are you using. So on the weight of the vehicle, if you are using a car weighing a ton or half a ton, so 1,000 kilos or 500 kilograms. And this obviously changes the amount of energy you use, but it also changes very, very much if you move in a crowded environment or on an empty street, if you move fast or slow. So if you do some calculation, you see that to give the same transportation, to give the answer to the same transportation demand, even with the same solution, for example, personal mobility systems, so vehicles, you may spend an amount of energy or even 1/10 of the amount of energy, dividing the vehicle occupancy, but also making that trip with a lower power demand and the correct drive style and so on, vehicle speed control and so on. And also from this point of view, ICT, information communication technology, which completely change the perspective in the next decades. So from a vehicle use level point of view, many innovations are expected to happen in the next 10 or 15 years, which may have an impact which could be even more disruptive than those at a technology level. Obviously, an expected impact is already coming from a vehicle production level, because it's now 3 or 4 decades that the vehicle producers are working to reduce vehicle emissions and to reduce vehicle toxical and greenhouse gases emissions. Firstly, they worked from the 80s onwards only on toxic emissions, so CO, HC, particulate matter, and emissions, and unburned hydrocarbons emissions. But now, at least in Europe, but similar things are happening overall in the world, a very detailed attention is given also to the overall energy consumption of the vehicle, and therefore on the CO2 and greenhouse gases emissions performances of the vehicles sold and used within the world. Obviously, to reduce energy emissions, you must reduce at first the weight of the vehicle, maintaining the same resistance, rolling resistance. So using aluminum alloys, for example, or composites, wherever you can. Obviously, maintaining rolling resistance, but also maintaining the resistance performances, the strength of the vehicle in terms of resistance to an impact. This, on its turn, it's maybe too high And what I mean that the performances we require to a vehicle in terms of its mechanical resistance will probably be reduced very, very much in the next decades. Why? Because of two main aspects. Firstly, as I explained before, a vehicle would probably be dedicated to a context. What I mean? I mean that more and more vehicles will be produced for a single application. And also performances will be different for the vehicles for different applications, which is not the case now. A vehicle for urban applications, what we think at as a vehicle for urban application, for example, the one represented here in the slide, a small vehicle, should have for our actual laws and directives should have the same performances in terms of mechanical resistance and in terms of toxical emissions and greenhouse gases emissions of a vehicle for extra-urban high-speed application. Exactly the same performances. Why? Because there is no restriction at all that this kind of vehicle, even a very small vehicle, may not be used for more risky context in terms of impacts, or on the other hand, for less risky. There is no restriction about the fact that a very high speed and high mileage and low and high size vehicle may not be used on the other hand in urban context. So a high speed highway vehicle can go in the city centers, and so its toxical emissions may be adequate for the city center as well. This was the direction given to vehicle evolution in the last 3 decades, but there is no logic in this. There is no real logic in this. Obviously, it is the way which is preferred by the manufacturers. Okay, but there is no real environmental and energetical reasons why the technology innovation should go this way in the next decades. I hope that the directives, the emission directives and the energy directives in the automotive sector will strongly differentiate the performances in terms of resistance, mechanical resistance, and in terms of environmental performances of the vehicles, depending on the context that we have to, in which we have to, and we are forced to use these vehicles. This means that this could mean that a vehicle for urban application could weigh probably only 200 kilos. And nowadays it doesn't weigh less than 500. Because if it goes to at mostly 70 or 80 kilometers per hour, and in urban context, it is not prescribed at all that its mechanical resistance should be so high, for example. But on the other hand, it should have a very, very high energetic and environmental performance in terms of toxicity emission, which a higher size vehicle simply cannot have anymore. The other aspect, as I told you, is again an ICT evolution. In the next decades, a very huge innovation is foreseen about assisted and autonomous driving, and this will give safety issues. This will make safety issues less and less restrictive. So we may remove some mechanical issues, accepting more critical damage of the vehicle if an accident occurs, removing as soon as possible, as highly as possible, the accident occurrence. So the automotive sector will more and more in the next decades, become similar to the aerospace sector, which are very high.
ايوه بقول ليش مش هذا بدرس لساعة اسبرين بقول يعني ما مش معقول انه
please mute your mic.
هاي المشكلة.
What يا سارة؟
Carlo, please unmute again. It's all muted.
Okay. So I was speaking about safety and the safety issues and the importance it has to also in terms of environmental impact of the vehicles. I explained you that the automotive sector will more and more be similar in the next decades to the aerospace sector. So cars will be designed and produced with very high safety coefficients, but in return the mechanical performances will be lower, and so that the energy consumption will be lower and the emission and environmental performances will be higher. And this will change the perspective very much in the automotive sector as well. Coming to the propulsion system level, which is maybe the one which is of your interest more, obviously much can be done. And propulsion systems are already changing very much. In Europe now the standard is what we call the Euro 6, which is already now, while we are speaking, not anymore 120 grams per kilometer of CO2 per kilometer, but 105. It's a very high efficiency and low emission standard for vehicles, what we call low emission vehicles. But those vehicles are, even though very few emitting and energy consuming, are not adequate anymore already for a urban context. So in urban context, the attention is focused to ultra low emission vehicles or to zero emission vehicles. Ultra low emission vehicles are low emission vehicles equipped are mainly hybridized low emission vehicles. Michele before was starting to speak about the hybridization and of the use of internal combustion engine in hybrid vehicles. This can certainly be done And this can give a substantial contribution to overcome the limits we have in an internal combustion engine, which is mainly due to the instability of the operation point of the engine. As Michele
عندنا ميكانيكا عام الجنرال احسن شيء
was
طبعا
explaining you
100%
before, and the instability of the engine operation point may be substantially the stability of the engine operation point for a given path, for a given transportation mission, can be substantially bettered through hybridization, through the hybridization of the vehicle, having the possibility on board to use also energy storage systems and additional energy sources to give energy to the road, so to give energy to the vehicle and fulfill road demands without changing the operational point of the thermal engine on board. So saving emissions, saving energy, and with the same transportation performance. On the other hand, there are the zero emission vehicles. With zero emission vehicle, we define a standard which was created in California many years ago, which has a zero emission on the emission point. So on the car level. For example, a battery electric vehicle have zero emission, is a zero emission vehicle because it doesn't emit any toxic pollutant during its use. To do this, it uses an energy vector, which is different from traditional energy vectors. For example, gasoline and diesel fuels, but also other fossil vectors like CNG, LPG, and others. Using electricity as an energy vector, obviously you get a zero emission of the vehicle on the place of its use. But please consider that the emissions overall depend on the way you produce, transport, and distribute the energy vector to its final use. So from the energy sources you use in the energy vector production, and on the technology you use to produce the energy vector from this energy source. So it depends on the technology choices you do within the whole energy sector, not only in the transportation sector. This means that the impact of the introduction of electric mobility differs very, very much depending on the context. The impact of greenhouse gases emission of the transportation sector is much, much higher, for example, in France than in Italy or maybe in Jordan as well. So the impact of the substitution of a traditional vehicle with an electric vehicle is much, much higher in this context, in which the electricity may be produced with no greenhouse gases emitting energy sources, including nuclear energy. So not only including renewable sources, but also including nuclear energy, which is an option for many countries still, which is not an option in Italy. I don't know if you know, but Italy is one of the countries in the world which chose in the 80s not to use nuclear energy. So we are completely nuclear free from the energy perspective point of view. So now we have a very, very lower impact of introducing electric mobility. So for the same number of electric vehicles sold in Italy, we have an impact on greenhouse gases emissions for the country, which is much, much lower than in many other countries in the world. And also this must be considered. This is one of the aspects you must consider in technology evaluation. So and we will focus on this in the second part of the presentation. So the impact of the technology you introduce is not only limited to the technology usage phase, but to all the phases which are impacted by technology use. So if the technology, a vehicle, uses an energy vector, you obviously must focus on the implications of a technology, of a new technology introduction in the other sectors which are connected to this. So on the production of the energy vector you need, on the transportation, distribution of this energy vector, on the energy sources you use, and so on. All the phases must be considered in the balance. What are the options from a propulsion system point of view? We have available already now. We may use in this slide, all the options are summarized in different paths with different colors. I hope this slide is sufficiently clear. You have all energy sources. You may use all energy sources to drive a vehicle. Maybe you may think that it's not possible to drive a vehicle with, let's say, wind energy. Yes, obviously, directly, it's at least very, very complicated to drive a vehicle with wind energy. But you may do this in a certain point of view. If you use, for example, an electric vehicle whose electricity is produced by wind generators. Okay, so you must consider the whole path and the whole phases which are connected to the technology used for the transportation sector to fulfill the transportation demand, which is a mechanical energy requirements, obviously, a movement needing. Okay, so you may use the renewable sources, solar energy, biomasses, wind energy, also ocean energy, geothermal energy, hydropower, and so on, to produce electricity mostly, because most of the renewables are particularly well coupled with electricity production. Then this electricity may be transported in long distances. So electricity may be a very important and sustainable energy vector, because it may be transported at long distances with very low losses in high voltage transmission devices. But electricity may also be, especially for the transportation sector, may also be transformed as well in other energy carriers. For example, the most one of the most interesting paths may be the production of hydrogen from electricity through electrolysis of water, so using water, because hydrogen is not an energy source, it is an energy vector, because the availability of hydrogen in the earth, in the environment, is very, very low. So we cannot consider hydrogen as an energy sector. We must produce hydrogen from various sources for our purposes, industrial and transportation purposes. Nowadays, hydrogen is produced from methane through a biochemical reforming, through a chemical reforming. It may be produced also from biological sources through biochemical reactors. But obviously the more interesting paths for hydrogen production is what we call the green hydrogen path. So producing it from electricity from renewables through electrolysis, which is the most interesting path for hydrogen production. So both electricity and hydrogen, as well as fossil sources, petroleum and natural gas, may be energy sources for transportation. Normal choice is based on fossil sources through the modification of petroleum into gasoline and diesel fuels, which are energy vectors and which are used in thermal engines. But this option should be removed, which highest possible speed in future, in the next future. I'm taking a bit more time than probably with respect to what was expected, because I think Michele is still not came back. So I'm using probably in the presentation part of the time of Michele, if you agree. Okay.
No.
Did you see Michele sharing us or not? Sharing our meeting? I think he still couldn't come. Okay, so I will go on. If you see Michele back, please stop me and I will give the floor to him to present his work as well. Anyhow, another possible path is from...
Maybe if you want, we can open the discussion.
No, I still haven't finished. Okay. I can finish in 5 minutes, or I can go on for hours. But okay. I can finish in 5 minutes, or we should be my hour from about, so that we will see. We will open the discussion and see if Michele will come later on. Okay, so I will finish probably in 5-10 minutes.
Okay, go ahead.
Okay. So another option may be biosources. So energy vectors which may be produced from biological sources like vegetable oils, but also methane can be produced by biomasses. And these energy vectors from a biological source may substitute in part or completely gasoline, diesel, and CNG, compressed natural gas, coming from fossil sources. On board, obviously, depending on the energy vector we choose, the choice for the propulsor may differ, because if we have a fuel, we must use a thermal cycle and an internal combustion engine. If we do not have a burnable fuel, if we have hydrogen or electricity, we may use other devices. For example, for hydrogen, we could use a fuel cell directly converting hydrogen properties into electrical energy. And for the traction, we could use electric devices. Those options may be not separated, but they may be together used in a vehicle in hybrid paths, which may be series or parallel. Michele should give you some detail about this. All these options are available. And also we could define on board, if we use an hybrid approach using both burnable fuels and other energy vectors like electricity in hybrid schemes, in hybrid propulsion schemes, we could also, we obviously must have an energy storage on board of one or two energy vectors, because one of the energy vectors on board could be, especially electricity, could be restored through the other one. So a vehicle could be its energy demands, its road energy demands fulfilled in 2 or 3 ways also by 2 or 3 energy vectors on board, but it could refill only or mainly with one energy vector. So the vehicle could be only refilling fossil sources, and on board it could use 2 or 3 energy vectors. So in hybrid schemes, one of the main important aspects to focus on is the vehicle electrification. So the amount of energy which is given in electric form on board, the ratio of the energy given for transportation purposes electrically with respect to the total energy demand. This is the vehicle electrification degree, and it affects very, very much the propulsion systems and also the performances, both energetic and environmental performances of the engine. You have traditional engines and propulsion systems on a side. You have battery and fuel cell electric vehicles on the other side, but you have a number of different possible options in the middle. These are scenarios. There are a number of scenarios for the next decades, more aggressive or less aggressive, more green or less green. But all of these foresee a very, very huge amount on the new sold, on the sales of light duty vehicles, for example, of hybrid, plug-in and full electric vehicles in the future. The selling share of those kind of propulsion systems which will go higher and higher in the next decades. So the automotive sector, especially within the transportation sector of the world, will change very, very deeply and very, very fastly in the next decades. Electricity is not new. Electric vehicles, electric traction, electric mobility is not a new technology at all. The first vehicles were electric. The first electric vehicles was built in 1840, so more than 150 years ago. And so what are the main technological problems to be solved? The main technology challenges are still on energy storage system, not on the electric propulsor, but also the propulsion sector is doing fastly great steps ahead. But what is really changing the perspective is the evolution of the energy storage technology, which still are not completely adequate in terms of energy storage capabilities, specific storage and power performances, energy and power storage performances are still not high as they should be for all applications. They are high enough nowadays, and the problems is now mainly on costs of the technology, but the performances are high enough for urban application. Why for urban application? Because in urban application we need less storage capability in terms both of power, specific power 4 kilogram of storage device, and both in terms of energy, because we need a shorter mileage of the vehicle, and because the vehicle weighs very, very low, may weight very, very low, especially if the consideration which I made before will be applied in the next future. So the perspective in the future is certainly that electric applications will cover the most of the urban applications. On an extra-urban context, the solution still is not electric mobility, from my point of view, because the electric storage performances for high mileage application affect too much the vehicle weight. So if we give a vehicle 500 kilometers of mileage, which is still too low, we are affecting the vehicle weight of by 30%, 40%. So we are increasing energy consumption of 30%, 40%, and this is not a really good way of solving the problems of greenhouse gases at all. There are more effective and performant solution nowadays for the long mileage, for the extra-urban context with respect to electric mobility. The problem is that manufacturers must solve an acceptance problem about electric mobility through the consumers, to the buyers, which want a vehicle which could give any performance like the traditional vehicle. But this is not a really good way of solving environmental problems at all. Okay, so widening the angle and coming to the title of the presentation I should give you today, but I think all this discussion would be clear only introducing all these energetic and environmental constraints before. Widening the angle, the demand for mobility may be fulfilled in a much more sustainable way in the future with respect to what we do now, but the solution may not be unique, may never be unique. It depends on too many constraints which vary depending on the applications, to think that a solution will overcome the others in all the context. So we will certainly see electric mobility in the urban context. We will probably will not see electric mobility introduced in extra-urban contexts so much in the next decades. All the solution must be compared. How could we compare? One, there are two possible options. One is a well-to-wheel approach, and the other one is a life cycle assessment or analysis approach. The more consolidated one is the well-to-wheel approach. In Europe, well-to-wheel evaluations are made by a pool of research centers and of manufacturers and also sources, energy sources firms which cooperate to have reliable data. The reports are done then by the Joint Research Center of the European Community, which is JRC. The latest report about this is the one I show you here. You can find in the internet easily and download. What is a well-to-wheel approach? A well-to-wheel not only considers the tank to wheels, so from the tank to the wheels, contributions to greenhouse gases, energy consumption, toxical emissions, but also considers all the phases which have to be faced to produce, transport, and distribute and fuel the fuel to the tank. So for a kilometer of transportation demand fulfilled, we must calculate the energy consumption in all the phases due to the usage of the energy vector in the propulsion system, and also, for example, the greenhouse gases emissions due to the overall chain. If one focuses, in fact, only to the tank to wheels part of the path, may overestimate the wellness, the performances of some technologies like plug-in electric vehicles, fuel cell electric vehicles, range extender, battery electric vehicles, but could also overestimate in part the effect of hybrid technologies, because taking the electricity to the tank may, dependently on the energy context, affect very much the energy performance of the overall of the propulsion systems and the greenhouse gases emission of the vehicle, considering the all well-to-wheel path. I will not focus deeply on all the paths and on why the results are this, but in the report I showed you, I can also give directly the PDF of that report to the coordinator if you need from JRC. All the solutions are compared. On this end, you have, on the left hand, you have, for example, in terms of energy expenditure or energy consumption, gasoline vehicles. The calculations are done on a middle-sized sedan car. This is diesel conventional engines. And in green bars, there are biofuels options with various different paths in productions of the biofuels. Also CNG, LPG here, I know it's very, very little. CNG here is considered, both coming from a biopath and from, this is, for example, synthesis, biosynthesized natural gas. And also electric propulsion is considered here, and also fuel cell vehicles are compared with normal cars, both from an energy expenditure point of view and of an energy consumption point of view, from a well-to-wheel performance, and on a greenhouse gases emission. And here you see, for example, biomasses may have a substantial bettering in performances with respect to fossil fuels. But also hydrogen and electricity may have a substantial bettering with respect to conventional approaches in transportation. But all depends on the context. Here, the JRC evaluation are made on what we call mix 15 or mix 27. So on the mixed European way of producing the electricity in all the states. But as I told you before, Italy attitude is very, very different from France, from Germany, or Romania, or so on. Lastly, this is, I think, my last slide. An LCA approach could be used to compare the solution, but this becomes more and more complicated. This becomes more and more complicated. What is an LCA approach? An LCA approach is a life cycle approach. Life cycle means not only the usage phase of the product, but also the production and the final and the disposal and recycling of the product itself. So it considers the overall life of the product. The product is, in this case, a car. So a well-to-wheel approach, even though considers only also the energy consumption and the greenhouse gases emissions, which are due to the production, transportation, transmission, distribution of the energy vector, and it must consider this to give a reliable evaluation of the product, only considers the usage phase of the production. But this car must be produced itself. So you must consider also the raw materials which are used in a car, the energy cost of the car manufacturing, and so on, and the final use of the car itself, so the recycling of the materials used. And all these are have an energetical and an environmental impact, all these phases. Obviously, the usage phase is the more contributing, but this mostly depends on the utilization factor of the vehicle itself. So if we produce a vehicle, we should use it up to its death. We should use it as much as we can. We should kill him. We should use a car as much as we can, because all the materials, the cost of production, energy cost of production, all the effort we should do to recycle this car later on, and so on, may be afforded only if we use this car for as much as possible to fulfill transportation demands. But nowadays we must we use cars with a very, very low utilization factor, so that these cars can become old and we must substitute those because of their low environmental performances too fast, too early, before they fulfilled their scope. So LCA approach, is it viable or not? It is very, very complicated to use a complete LCA approach. Well-to-wheel approach, even though complicated as well, is viable and considers only this phase, use and consumption, which is the most important phase, so that at least from a European point of view, well-to-wheel approach is the consolidated one. But obviously, LCA approach is important, and but it's normally dedicated to components. So you may have an LCA of a battery compared with, or electric energy compared with fossil fuels. You may have a detailed LCA approach, but normally you don't have an LCA of a vehicle itself, a complete LCA approach comparing the two propulsion systems. LCA, to complete, it's very complicated because it should, for all the phases, define the goal and scope of the aim, but also this phase is very, very crucial. Inventory analysis. You should have detailed and reliable data about all the phases, about all the material used, about all the manufacturers, about the recycling phases of all the components. So it's a very, very, very complicated approach. So this finishes my presentation. I've been longer than expected, but I used part of the time of Michele. I thank you all for the attention. I hope you could follow me.
Thank you, Professor Carlo Vellante from the University of L'Aquila, UNIVAC in Italy. Maybe we can open the discussion now. Anyone have any question to Professor Carlo? Please go ahead. And once we have Professor Michel, we can start with him.
Yes, give me just 1 minute. I call Michele and I see if Michele is available or he thinks he can join us or not anymore. Just a minute and I will answer your questions.
Okay.
Please, everyone, we will provide you with an evaluation link in the chat. Please evaluate our workshop so you can get your attendance. نرجو منكم جميعا تقييم ورشتنا لهذا اليوم من خلال الرابط الذي سيتم تزويده في الشات، ومن خلال من يقيم الرابط سيحصل على شهادة حضور لهذه الورشة. شكرا لكم جميعا. سنفتح الآن باب الاستفسارات للبروفيسور كارلو ومن ثم سنعاود للسيد بروفيسور ميشيل. Yes, Professor Carlo.
Okay, I spoke with Michele. Unfortunately, he couldn't solve still the problem he has with his personal computer. He's very, very sorry, but he cannot join us for this conversation. But I can answer also to, questions about the part he did or to your doubts about internal combustion engines as well. No
لو عنده أي سؤال يتفضل.
كنا احنا نسلم عليك استاذ ياسر، الوحيد اللي تعرف فيه ما حدا.
مستر هلال لو سمحت، لكن صوتك واطي.
اهلا وسهلا استاذ، صوتي واطي يعني؟
يس. Yes, please.
واضح عندكم؟ It's very clear to you?
Yes, it is clear. Please go ahead.
We are very sorry because we have a visitor here in the college, so that's what I cannot attend earlier with you, but I will catch up now the slides and with you about the discussion, inshallah. And very thank you to all of you. We attend for you. This is by virtual meeting. Thank you.
Thank to you. Thank to you all. I expected a good participation, but I saw you are very, very many people. So it was a pleasure for us to share on this.
Yes, we have about 80 participants during our workshop. We are opening now the discussions. Please, Professor Salman, yes, please.
Yes, thank you very much for the very interesting presentation. Also, of course, thank you for coordination. This workshop that is very interesting and important for our project. So my question, Professor Carlo, about the possibility or developing of energy storage for the cars. As you see in one slide, you showed that with lithium lithium battery, maybe we can achieve till about 500 kilometers, or that was. But what about the prices for this? Of course, energy need or better technology need also more price. That is,
yes,
is very clearly. But about the specific prices, is this okay in this case that could we
okay
for this, but we have more energy, more benefits?
Mm-hmm. Okay, thank you for the question, Salman. That's a problem, indeed. Lithium-ion batteries are the solution nowadays. When you speak about lithium-ion, you don't speak about a single technology, but a set of technologies, a set of chemistries, of different chemistries. Some of them are have an high energy performance. Some of those have an high power performances. So if you choose lithium batteries for high energy application, for high mileage performances, you choose a technology. If you are looking at hybrid vehicles, for example, for urban applications, you may choose another chemistry, another lithium-ion technology, which is mainly which has mainly to give you power performances. Okay, so summarizing, you can have 500 kilometers mileage. You can. But nowadays you must choose very high energy performances lithium-ion batteries, which cost very much.
Yes, of course.
And still weight too much. So you can do it. You pay for the batteries nowadays for this kind of performances about an overcost of about 40–50% of the vehicle. And you see this on the manufacturer's cost, but manufacturers now are trying to sell these vehicles. So the costs are maybe a bit underestimated, the industrial costs for the moment. But the more important fact from my point of view is that okay, if you can pay it, okay, you pay it and you buy the vehicle. But and another aspect is that the batteries do not last the same that the vehicle. So you must substitute the batteries once or twice during the vehicle lifetime. So this may be affordable if it is a low percentage of the vehicle cost overall. But if you must substitute the 50% of the cost of the vehicle twice or 3 times, if you are
that is very much.
lifetime, it's very crazy. Okay, it could be really unviable for the manufacturer as well. This is one problem, one part of the problem. The other part of the problem is environmental. Okay, because it really doesn't make any sense to increase the weight of the vehicle of the 50% only to use electricity, because there are others viable solutions for high mileage, for highway vehicles and so on.
Yes,
Which are environmentally more performant and more green than electric vehicles, if you consider the whole well-to-wheel chain for that application. So the only reason why nowadays the mileage of an electric vehicle is going higher and higher is to sell electric vehicles, because consumers want a vehicle that can give him all the performances, all the which could not constrain its use later on. Okay, but as I explained, as I hope I was clear, but as I explained in the first part of the presentation, I think that we must change the perspective. We should have more and more in the future vehicles, cars, transportations for urban context, detailed to urban context, and other vehicles, other transportation solutions for high mileage, highway context, which can also pollute, because we maybe are concentrating our attention too much on the pollution of sport utility vehicles, which is nowadays very, very low, very, very low. But the problem is that we use those sport utility vehicles, those big vehicles within the city centers, which is crazy. Okay, so the real solution is to avoid vehicles which are not made for a single application, urban context, to go in urban context. If that vehicle goes in highway context, it can pollute also more than that, because we will not breathe those pollutants. So I think things will change very, very much in the next future. So, but battery energy storage is one of the main problems for electric mobility.
Yes. Okay, thank you very much.
Thank you.
Thank you, Professor Salman, for your participation. Dr. Aktham, please go ahead with your question. You are muted, Dr. Aktham. Please unmute.
Okay, sorry. I said good morning, everybody, and buongiorno for Professor Carlo Vellante. Professor Carlo, I want to ask you something about the usage of electrical cars in Europe, and if they will be applicable by 2023, as they said before, and they were talking Europe, they are going to apply this usage of all the electrical car, and the other car for fuels will be finished, will not be used by 2023.
Okay, I think I catch your. I couldn't hear you so well, but I think I catch your
okay,
question.
I can repeat it, maybe.
No. Okay. I will try to answer. Then tell me if you.
If you want, I can tell you in Italian, no problem.
Okay. European Union is going very, very fastly towards emission reduction. The path European Union is designing is very, very strict. You spoke about very fast removal of traditional engines from the European Union. I don't think it will be so fast, but I think that very, very fastly European Union will force the administrations to restrict the applications. So to permit electric mobility in urban context as the only possible viable mobility. So only in restricted context, maybe not 2023, but some years, a couple of years later, this will be done. Okay, so the urban context, which represent about 30–40% of the energy consumption overall and 50% of the emission problem overall, will be restricted to electric mobility. This means more, not only that a substantial part of the vehicles sold should be electric, but the 100% of the vehicle used in this concept should be electric. So a very, very fast transition. I think this can only be done with not only with private people contribution, but with firms' contribution. As I explained, I think that European Union and the administration will ask for a very, very high contribution of big firms to give transportation services within the urban context. So what I expect that the main firms within Europe, which are mainly devoted to the energy sector, to the energy production, and also to ICT, will become the primary actors in selling electric cars and in selling transportation services, which will be the only way to fulfill our transportation demand within the urban context.
What is the
I think, for example, in Italy, this may restrict the application to for 2025 to Milan, Rome, maybe Turin, Bologna, and not many other contexts. The other contexts will be still free, let's say.
Okay, okay.
But these 4 or 5 big cities still represent 30–40% of the problem overall. So a huge transition.
Okay, thank you very much. In bocca al lupo.
Viva il lupo.
Speriamo. Grazie molto.
Thank you, Dr. Aktham. Please, Yusuf Mihyar.
Thank you, Mr. Carlo, for the very interesting presentation. I just have a small question. Do you think that the energy storage problem will be solved by the introduction of the solid-state batteries, which boast higher energy density and a longer life cycle?
Okay, solid-state batteries are certainly an option. Is an option which I also experimented on a research center scale. It's a viable solution, but still doesn't have the TRL, the technology readiness level needed for this kind of applications. First, we will see those kind of storage systems like the past coming for ICT technologies, smartphones, and so on, and then maybe for cars and for transportations. It will take a bit of time. For the moment, some of the lithium-ion technologies are already a solution for urban application. As I explained, still not the solution for all contexts. So the technology evolution in this sector is still needed. to reduce costs, to reduce the raw material use, because lithium is not so available in the world, and other metals as well have a problem of exhaustability. So solid state batteries can be an option, and certainly will be the option in the next future, but I don't think that will be used for transportation in the next years. So let's say it would need a decade, about a decade, I think.
Okay, thank you. Thank you, Dr. Carlo.
Thank you. I think we have Mr. Majid Swaiti. He wants to ask a question. Mr. Majid or Mr. Akel?
Yeah, Majid Swaiti with you. Truly, I get access by using my friend link, so it's comes as Akel. Akel name. Yeah, Majid here. Yeah, I want to ask the professor if you can let me that start the professor, please. Hello?
Yes, we are. Yes, we are hearing you.
You hear me?
Yes, not so well, but we hear you.
ممكن تعلي صوتك لو سمحت؟
Okay. Now, did you hear me now?
Yes.
Did you hear me now?
Yes.
Yeah, it's better. My question is, did you think they are changing the cycle of motor from auto to Kenson, sorry. That's to keep the environment about pollution or what?
Sarah, I don't know. I cannot hear him so well. Maybe you can, if you can, you can.
Maybe you can send your question on chat and.
Okay. I write in my chat.
Okay, perfect. Mr. Muhannad Al-Ramahi, you are having a question as well. Please go ahead.
Yes. Thank you, Mr. Carlo, for this nice meeting and conversation. I have one quick question regarding the hydrogen vehicles and hydrogen, the new development that we are seeing these days, and it will be a threat for electric vehicles or not?
It will be.
What is the difference between the hydrogen and the electric industry in general, and why we didn't speak about the hydrogen the hydrogen cars and this invention?
Okay, so hydrogen is certainly an option. One of the main, hydrogen can be used in vehicles in many ways. Some manufacturers tried, especially in the past, to use hydrogen as a fuel in an internal combustion engine. You maybe know BMW had this, tried to use this approach. Obviously, if you use hydrogen burning it, you have an issue, a problem with NOx, with NOx. So you have some toxic pollution as well. So you don't have a zero emission vehicle. The way to use hydrogen in vehicles as a zero emission vehicle, so as a very green vehicle, is to use it through fuel cells. This is the problem, because in the last 20 years, the fuel cell sector maybe was expected to have an increase, an amelioration higher than what it did. If we looked at the fuel cell vehicle option 20 years ago, we were maybe more optimistic, because hydrogen has many advantages with respect to electricity, because it could be transported and distributed easily. It could give vehicles easily an higher mileage with respect to electricity. So a fuel cell vehicle would have many more advantages with respect to a battery electric vehicle. But fuel cell still is a very crucial part of the problem to be solved. The only solution nowadays is to make the fuel cell work steadily, so on a steady operation point.
I see.
So if you do like this, and if you give the attention to urban contexts, which are the ones in which the environmental problem is highest, you, on the other hand, do not have a steady operation point at all.
I see.
So you must hybridize the fuel cell vehicle with a substantial electric storage system. So all the fuel cell vehicles are hybridized. The competition then becomes from with electric vehicles, but in a way, also a fuel cell electric vehicle is an electric vehicle as well, and has a battery electric storage on board. So let's say I think that hydrogen is, for the moment, hydrogen applications are limited to those contexts in which a steady operation for the fuel cell may be more viable, so that you can substantially reduce the sizing of the electric storage on board and use technology not so costly and not so and viable. One of these contexts, for example, is railways.
Yeah.
For railway application, for example, I think fuel cell trains may be a viable and let's say explorable, really industrial solution. Okay, we are having some experience in Italy on fuel cell trains. We will have those experience also here in L'Aquila probably in the next years. I think this could be a first sector in which hydrogen transportation can be an option.
Thank you so much.
Thank you, Mr. Muhannad Al-Ramhi, for your question and participation. Dr. Carlo, we have a question here in the chat. Maybe we can read it and answer on it.
Okay.
Yes.
Okay.
Sorry, by mistake, I write four-wheel drive.
Okay.
I want to write four-stroke engine.
Okay. Okay. Should be this one. Do you think that converting the four-wheel drive cycle from Otto to Atkinson is due to environmental reasons or to the nature of the work of the hybrid systems? Okay. Atkinson is a particular cycle, has some advantages, which are, as you said in the question, connected both to environmental reasons and more to the possible coupling of the Atkinson cycle in hybrid systems. What I mean, that Atkinson cycle was not so used, was not used at all before in transportation, because the let's say Otto and diesel cycles were mostly were more capable with very rapidly changing transient requirements. Okay, because on the other hand, Atkinson cycle could have some attitude to have a lower, to have an higher efficiency and a lower environmental pollution with the same amount of energy given. But not in transient operation. So if you use it in, if you think to use it in an hybrid system where the hybridization help you to make the internal combustion engine more stable, Atkinson cycle may become an option as well. I hope I answered to your question. Okay.
Is it clear, Mr. Akel? Yes.
Yeah, Majid, please correct the name. I use my Mr. Akel link, so it comes Akel, but truly I am Majid.
Okay, I'm afraid I don't understand.
Yeah.
Okay, but I hope I answered your question. Okay.
Yeah, it's clear. Yeah.
I also saw
Thank you.
A question when we expect our vehicles are hybrid and...
Yes, from Mr. Ahmed Al-Qadiri, please go ahead with your question. Ahmed Al-Qadiri.
Hello, Mr. Carlo.
Yes.
For your lecture. I have 2 points to talk about, if you let me. First one, we are talking about the most benefits way in automotive industry for the environment. You talked about tank to wheel. I wonder about wheel to wheel. I mean the life cycle of the vehicle from the materials production to the end of the life vehicle.
Yes.
And recycling the materials. In this way, will it be still more advantageous to the internal combustion engine? Second question is, what are you looking for the most? More battery capacity and mileage for the vehicle, or keeping good environment? In a hybrid vehicle or electric vehicle, they use lithium or nickel. Lithium are most likely to pose high supply risk, but nickel has a medium range of supply risk. While lithium use more capacity and more mileage. So, yes. What is the best for you?
Okay. Okay. I forgot the first question. Okay, the second one is on lithium. Certainly, lithium has some. Okay, I remember also the first question. Okay, the second question is about lithium. Certainly, lithium nowadays has still some problems about availability, especially of a medium time horizon. Those questions must be solved, obviously. Let's say that still is not so certain that this solution can afford, can solve the problem with the amount of vehicles that should be produced and sold on a worldwide scale in the next years. So it's a challenge. It's a very facing challenge. The availability of lithium, the recycling of lithium, and so on. So it certainly is a problem. The first question was about tank to wheel, well to wheel, and LCA. Certainly, tank to wheel, comparing transportation schemes and transportation solution only from a tank to wheel perspective is not correct. It's not correct at all. It could be correct if one only gives attention to very restricted context for example, urban context, you only need to reduce pollutant emissions. Okay, you only look to tank-to-wheel emissions. Obviously, you don't care about what you do before. But since the problem is not only the pollution in urban context, but we have many problems to face, we must look to possible alternatives, at least from a well-to-wheel perspective. So including all the energy consumption and emissions, especially greenhouse gases emissions due to the production, transportation, distribution, refilling phases of the energy vector chosen for that particular application, and including in the balance all this well-to-tank emission and energy consumption, as well as those given by the final use phase, so for the tank-to-wheel phase. An LCA approach is a different approach with respect to a well-to-wheel approach, because LCA life cycle assessment not only considers the usage phase of the product, so of the car, but also considers the production phase and the ending phase and the recycling of all the materials used in these applications. Obviously, an electric car and a conventional car are different from this point of view, because at least now, all the production phases for electric car and all the recycling phases for electric car will cost very much, because the industry is partially not prepared in all these phases. And so, at least on an early stage, all these phases, production, energy consumption, and greenhouse gases emissions due to car production and due to car recycling and end of life, could wait for a substantial part of the overall LCA assessment. It's anyway very, very difficult to have LCA data reliable and consistent to evaluate all those aspects. At a European Union level, let's say the well-to-wheel approach is the one which is more consistent, which is believed more consistent and reliable to compare possible transportation solutions. I hope I answered your questions.
Yes, but the second questions, can I reform the question again? Okay, so in electric vehicle, we have mostly two kinds of batteries, lithium ion and nickel metal hide, tamam? Okay.
Yes, but mainly nowadays are lithium ion.
Yeah. Lithium are more risk for the environment than nickel.
Yes.
In the other hand, lithium have more mileage. So why companies all are going to lithium, not nickel?
Yes, because yes, I understand your question. Because nickel molybdenum batteries were already present, and they, let's say, were believed not to be viable from an industrial point of view in terms of balance between costs and I mean experiences with electric vehicles with those kind of batteries is possible, but I mean the manufacturers believe that as a business case, let's say, lithium ion is more consistent. Obviously, from an environmental point of view, nickel has nowadays still a better performance. than nickel, than lithium, but have problems in terms of mileage, which substantially affect the possibility to have cars sold in the next future with this kind of batteries. Because on the other hand, other chemistries like lithium, but also solid state, are maybe not today, but perspectively in the next decade, much better. Okay, so as far as I know, I'm not a chemical energy, I'm a mechanical energy, but I have some experience also on energy storage devices. As far as I know, the chemistries based on nickel are not expected to evolve so much in the next future, while a very huge evolution in terms of performance is still foreseeable for lithium. Okay.
Yes, thank you.
So that's why the manufacturers are mainly basing on that, and are making, all the manufacturers made bilateral agreements with battery manufacturers. So they are working together on the evolution of single battery packs.
Many thanks, Mr. Ahmed, for your participation. Do we have now any further questions to Dr. Carlo?
Yes, from Mohammed Masad.
Yes, please go ahead, Engineer Mohammed Masad.
Good afternoon, everyone, and many thanks for Professor Carlo for his presentation. My question is about the high voltage batteries. We know that in EV, the batteries takes about 40 to 50% of the vehicle. What do you think about the import of used HV batteries from outside, for example, here in Jordan? Do you think if we take into consideration of environmental issues, do you think it is good or not?
I think I catch your question. You were speaking about high voltage batteries.
Yes, the used high voltage batteries. About the import of these batteries to Jordan here, it is good or not?
Yes, but I mean the voltage of a battery pack depends on the. I'm not sure I guessed the question right. You are still speaking about lithium batteries.
Yes.
Okay. So when you assemble a battery pack, you start from a single cell that has a, let's say, 4 volts open circuit voltage. Okay. Now the voltage of the battery pack overall is a design choice that depends on the power and energy requirements of the car. So you normally adjust the voltage of the battery pack depending on both the power and energy requirements of the vehicle, trying not to overcome a certain level, considering that obviously having a higher voltage at the battery pack means that you have lower amperage, lower current for the same power on board. So you reduce the Joule effects losses on board. So if you have higher voltage battery packs on board, you normally have higher efficiency on board of the electric system, but you normally do not overcome certain values because over that you may experience safety restrictions for the voltage level on board. So it depends on the application, but if you look, for example, at a bus application of a coach application, you may come to voltage level up to 600 volts. And this may change your directives in terms of wirings of the car. So you go, at least at a European level, on another directive, which is much more strict and severe for wirings and safety issues. Okay, so you normally stay below this voltage. At least this is the choice from the manufacturers, accepting an higher amperage, an higher Joule effect losses, not to go on another category of vehicles. Okay, not to be restricted for safety reasons in wirings and so on. But normally for cars, power and energy demands are not so high, so you remain at about 200, 300 volts and acceptable amperage below 200 amperes. It depends on the powers you have to fulfill. If you have 200 volts and up to 200 amperes, you can give at most 40 kilowatts of driving instant power. If you need more, you must accept an higher voltage or an higher amperage, at least for very short, limited periods.
Yeah, Professor. Thank you very much for your answer. I think that now it is 12:30, even that we have some colleagues who would like to have questions. So I think that we can maybe, if you can maybe send anything you need maybe by email, because I think that yeah,
it's not a problem for me. If you want to just send an email to me, you have my email. I can write it here in the chat.
So some of the colleagues will visit also your university, hopefully that after a few months, as soon as we finish from this corona, from this COVID-19, hopefully that will be able to visit you also and visit Italy, visit your institute. And in fact, on the behalf of all participants, would like to thank you very much for your presentation and for the discussions. I would like also to thank our colleagues who joined this meeting. I think that and this workshop was very successful. So many thanks for all of you. Please don't forget to evaluate the workshop. Engineer Sarah already announced or post, I think that the link for the evaluation. It will take only 2-3 minutes, not more from you. And if you need also a certificate, it will be also prepared and submitted to you, the certificate of attendance. يعني اسمحوا لنا اخوان احنا نشكركم جميعا يعني على حضوركم، وان شاء الله احنا بنضل على تواصل معكم وبنخبركم عن اي خلينا نحكي عن ورك شوب قادمه. يعني نتمنى لكم ان شاء الله يوم سعيد و would like to thank you all and have a nice day. Inshallah, يعني within I think that next month we'll have another workshop and also it will be announced with also other colleagues from I think that from Europe, might be from Spain or Italy or Germany. شكرا لكم، الله يعطيكم الف عافيه وان شاء الله نشوفكم على خير.
الله يعافيك، شكرا دكتور، شكرا يعطيك العافيه.
الله يعافيكم.
Thank you, Ahmed. Thank you, Ahmed. It was a real pleasure to give my contribution to the project. I will certainly give it more and more during the project also. And I think it was a real good conversation with you all. I wrote my email address in the chat, also that of Michele. So if you need to contact him, feel free to contact him. He is very, very sorry for the problem he had today. I tried to answer about also questions which were devoted to him. Me and Michele will give you the material of the presentations so that you can share with the participants, with the registered participants. And also they could look at Michele material, and if they have questions, they can ask him by email. Thank you all. Thank you, everybody. It was a pleasure for me.
دكتور احمد بس اذا تسمح لي قبل ما
Thank you very much.
دكتور احمد
تفضل.
انا بالغلط دخلت على اللينك بتاع زميلي لاني سجلت له لزميلي، فهو دخل على اللينك وانا دخلت على اللينك، ففي اسمين طلعوا، انا اسمي ما طلع. ما بعرف انت راح تمشي على اللينكات ولا على التسجيل على الايفالويشن؟
عملت الايفالويشن دكتور؟
عبيت الايفالويشن الان، وزميلي راح يكون عباه، وهو كتب اسمه في الايفالويشن بتاعه وانا بكتب اسمي في الايفالويشن.
والمشكله الصوت مش واضح فمش قادر اسمع منيح.
عندي انا عبيت الايفالويشن باسمي، وزميلي عبى الايفالويشن باسمه، بس انا داخل باللينك من عند زميلي فطالع اسمه.
ما في مشكله، طالما عبيت الايفالويشن باسمك تجيك السيرفر.
يعطيك العافيه دكتور، شكرا لك.
الله يخليك، شكرا لك، شكرا، اهلا وسهلا، شرفتنا. الله يعطيكم الف عافيه ونراكم على خير جميعا ان شاء الله. يعني ويوما سعيدا للجميع ان شاء الله. مع السلامه.
دكتور
تفضل.
لو في مجال ايميل دكتور كارلو.
Yes, I put it in the chat. I'm putting it again. I hope you can see.
You have the email in the chat if you see.
مش موجود.
It is yeah, it is for me only maybe or no.
I will do like this, Ahmed.
Dr. Carlo can't see your email.
Yes, here it is. You can see.
Okay, okay. Thank you.
Okay, excellent. Okay, great. So we'll have a nice day. Bye bye.
You all.